Alright, welcome back everybody. In this video we're going to continue with section 7.3 of AP Calculus, sketching slope fields. In the last video we looked at how to sketch a slope field and create some particular solution curves. In this video we're going to do a few parts from some AP exam free response questions that incorporated slope fields. So we'll go ahead and we will start with our example number 2 here, which is from the 2016 AP Calculus exam. This is AB exam free response question number 4. Well, a couple of parts of AP Calculus AB exam free response question number 4. It starts us with the lead-in. Consider the differential equation dy dx equals y squared over the quantity x minus 1. On the axes provided, sketch a slope field for the given differential equation at the 6 points indicated. Notice on your AP exam they are going to give you, clearly defined dots. They say that there are 6 points indicated. If you count them up, it's 1, 2, 3, 4, 5, 6. Those are the 6 points where you want to create your slope field. You do not need to create a slope field anywhere else. So what we want to do is we want to go ahead and substitute values in for x and y to find the slopes at these various points. So we'll start right here at the origin, 0, 0. If we put 0 in here for y and 0 in here for x, we end up with 0 over negative 1, which is just 0. So we'll draw in a slope hash with a slope of 0. Next point, 0, 1. So if we put 0 in for x and 1 in for y, we end up with 1 squared over negative 1. So we've got a slope of negative 1. Draw that slope in. And then if we put this other point in, 0, 2, we put 0 in for x, 2 in for y. That gives us 4 over negative 1. And so our slope should be 4 at this point. And I'm doing my best to make a slope of, negative 4. A slope of negative 4. Now we've got 3 more points to do here. Where x is 2 and y is 0, we end up with 0 squared over 1. So that's just going to be 0. At this point, 2, 1, we put 2 in for x and 1 in for y, and when we do that we have 1 squared over 1, so that's positive 1 is our slope line there. And 2, 2, we end up with 4 over 1, and so our slope line there should have a slope of 4. And there's part A to that question. All right. Part B, let y equals f of x be the particular solution to the given differential equation with the initial condition f of 2 equals 3. Write an equation for the line tangent to the graph of y equals f of x at x equals 2. Use your equation to approximate f of 2.1. Okay, so to write this tangent line, we need two things. Those of you who've listened to me before know these two things. We need a point and we need a slope. We're given the point 2, 3. And so in order to write the equation of the tangent line, we need the slope at this point. So we're going to take dy dx here, and we are going to substitute in the point 2, 3 and evaluate. So that gives us 3 squared over 2 minus 1. So we find that our slope is 9. Therefore, our tangent line is y minus 3, y minus y coordinate, equals the slope times x minus the x coordinate. And if I wanted to, I could write this in functional form. I can add 3 to both sides. And then the function here is, is 3 plus 9 times the quantity x minus 2. There's my tangent line. The only reason I wrote the tangent line this way is because it asks me to approximate f of 2.1. So I'm going to go ahead and substitute 2.1 in here for x. And we get that f of 2.1 is approximately 3.9. And that's our answer to part B. All right. There was a third part to this free response question, which we don't know how to do yet, but we will soon. And eventually we'll be able to talk about that part. All right, example 3. which is question 6 from the free response from the 2018 AP Calculus AB exam. Consider the differential equation dy dx equals 1/3 x times the quantity y minus 2 quantity squared. First things first, we're given a slope field this time. We don't have to sketch the slope field. We're given a slope field, and we want to sketch the solution curve that passes through the point 0,2. Notice they've indicated the point 0,2 on the slope field. And sketch the solution curve that passes through the point 1,0. Notice they've indicated the point 1,0 for us. Okay? So let's start with 0,2. The slope there is 0. And notice that all the slopes along this line are 0, so this solution curve will never get off of this line. And so, boom, there is our solution curve that passes through the point 0,2. The other solution curve passes through the point 1,0. You see that the curve goes up and starts to flatten out as we move towards the edge of the boundary. Something like that. And as we move in towards the middle, it goes like this. And then when we get to the y-axis, everywhere the slope is 0 on the y-axis. So the curve flattens out there. And then it goes off in the other direction, kind of mirror image of what I saw on the right-hand side. And there's a sketch of our solution curve that passes through the point 1,0. Okay, should I put, boom. All right, and then part B, let y equals f of x be the particular solution to the given differential equation with initial condition f of 1 equals 0. Again, we're writing a line tangent to the graph and then using it to approximate. So the first thing we want to do is we want to find dy dx at our point. The point that we have is the point 1,0. So we're going to put 1 in here for x and 0 in here for y. That's 1/3 times 1 times 0 minus 2 to the second. We end up with dy dx equals 4/3. So our tangent line is going to be y minus 0 equals 4/3 times the quantity x minus 1, or just f of x equals 4/3 times the quantity x minus 1. And now to use this to approximate f of 0.7, we're just going to go ahead and substitute 0.7 in here for x. And both of these questions were non-calculator questions, so these are the challenging calculations that I would have to do in my non-calculator section. But there we go, we get that the approximation is -0.4. All right, that brings us to the end of this video and the end of section 7.3, sketching slope fields. We're going to come back next time for section 7.4, which is more stuff with slope fields. We're going to do some reasoning and answering some different kinds of questions using slope fields. All right, until then, we'll see you. Have a great rest of your day, and talk to you when I'm talking to you. Bye-bye.